Hey everyone, and welcome back to the channel. Today, we re-dive in deep into another common but sometimes tricky fault code you might encounter on your heavy equipment. SPN 2659. FMI 20. This one translates to EGR flow below normal. If you've ever seen this code pop up, you know it can be a bit of a headache. But don't worry, we're going to break it down step by the end of this video. You'll have a solid game plan for diagnosing and fixing it like a pro. So, what exactly does this code mean? In simple terms, your engine's control module, or ECR, is expecting a certain amount of exhaust gas to be recirculated back into the intake, but it's detecting that the actual flow is much lower than it should be. This is a big deal, because the EGR system is crucial for reducing NOx emissions and helping to control combustion temperatures. When it's not working right, you might notice issues like reduced engine power, poor fuel economy, or even the engine running a bit rough. The first question is, how does the ECM even know the flow is low? It's all thanks to a few key sensors. Most modern engines use an EGR differential pressure sensor, a Venturi tube, or sometimes an EGR temperature sensor to measure the flow rate. The ECM compares the actual reading from these sensors to the value it commands based on engine speed, load, and other factors. When there's a significant mismatch on the low side for a set period of time, boom, it triggers the SPN 2659 FMI 20 code. Now for the fun part, troubleshooting. Where do you start? The most common culprit, and the first place I always check, is the EGR system itself. We're talking about carbon buildup. Over time, soot and carbon from the exhaust can clog up everything in the EGR's path. This includes the EGR valve, the EGR cooler, the Venturi tube, and all the connecting pipes and passages. A heavily restricted or completely blocked passage is the #1 reason for low flow. Your first step should be a thorough visual inspection. Start by removing the EGR valve. Take a good look inside. Is it caked with hard, black carbon? Can it move freely? Or is it stuck open or closed? If it's a mess, it needs a good cleaning or, in severe cases, replacement. But don't stop there. The problem often lies deeper. The EGR cooler is another major choke point. Cleaning these can be tough, and sometimes a replacement is the only practical option if it's internally blocked. Also, inspect the Venturi tube and the small ports leading to the differential pressure sensor. These tiny passages are very easily clogged and can give you a false low flow reading even if the main path is clear. If you've cleaned everything and the passages are clear, but the code persists, it's time to look at the components that control and measure the flow. Let's start with the EGR valve actuator. Is it getting the command to open? You can often use your diagnostic software to perform a functional test, commanding the valve to open and close while monitoring its position. If it doesn't respond, you could have a bad actuator, a wiring issue, or a problem with the driver in the ECM. Check the wiring harness for any signs of damage, like chafing, corrosion, or breaks, especially around hot exhaust components. Next up is the sensor side. The EGR differential pressure sensor is critical. If the sensor is faulty, it can send an incorrect low flow signal to the ECM. Check its live data on your scan tool. Does the pressure reading change when you command the EGR valve to open or when you rev the engine? If it's stuck at 0 or a fixed value, that's a red flag. You'll want to test the sensor's wiring, checking for power, ground, and a good signal wire back to the ECM. Sometimes, just the sensor itself fails and needs to be replaced. In some rarer cases, the issue might not be with the EGR system at all. Think about what else affects exhaust flow. A restriction in the exhaust system itself, like a plugged diesel particulate filter or a collapsed pipe, could potentially reduce the back pressure needed to push gas through the EGR circuit. Also, consider the intake side. A major boost leak could lower the pressure differential across the EGR system, tricking it into thinking the flow is low. So, it's always a good idea to check for other active fault codes that might point you in a different direction. So, to recap our diagnostic path for SPN 2659 FMI 20. Start with the most common cause carbon buildup. Thoroughly inspect and clean the EGR valve, cooler, and all associated piping. If that doesn't solve it, move on to testing the EGR valve actuator and its wiring. Then verify the operation of the EGR differential pressure sensor and its circuit. Finally, if you're still stuck, look at the bigger picture, including potential exhaust or intake system restrictions. Following these steps systematically will help you pinpoint the root cause efficiently and get your equipment back to work. I hope this guide was helpful. If you've battled this code before, drop a comment below and share what you found. Your experience could help someone else out. Forget to like this video and subscribe to the channel for more heavy equipment diagnostic tips and tricks. Thanks for watching, and I'll see you in the next one.